Math is broken, or at least that's what this equation wants you to think. Today I'm going to use basic algebra to prove that 2 is equal to 4. It looks airtight, it follows the rules of math and algebra, and yet it's obviously a complete lie. So let's dive into the power tower paradox. We can start with an infinite stack of x's. X to the power of x to the power of x to infinity equals to 2. Because this stack never ends, the exponent here, this portion here, is actually the same thing as the entire thing. So we can just swap the top for a 2. X squared is equal to 2. And then that would just mean that x is equal to square root 2. It's simple, right? But watch what happens when we do it again. Let's set the same tower equal to 4. X to the power of x to the power of x to infinity equals to 4. Substitute the top to a 4, and then x to the power of 4 equals to 4. And then we know that x squared equals to x to the power of 4 equals to 4, which is 2 squared. So once again, we have x squared equals to 2. X equals to square root of 2. And what do you realize? If square root 2 to the power of itself forever equals to 2 and 4, then 2 equals to 4? Well, this is obviously impossible. I mean, like, the math is screaming at us and it looks correct, but where's the mistake? The mistake is assuming infinity does not have boundaries. In math, this is called the Euler-Eisenstein Limit. An infinite power tower only works if the result stays between 1 over e and e. And that's about 0.36 and 2.71. So basically we want 1 over e and e to be the limits. So 2 belongs in here. Because 2 is less than 2.71, that equation is real. But because 4 is higher than the limit, that equation is just a mathematical ghost. If you actually try to calculate square root 2 to the power of itself forever, it will never reach 4. It will hit 2 and stay there. So the takeaway is that algebra is a powerful tool, but without limits, it's just a magic trick. Infinity is not a destination, it's a behavior. And sometimes that behavior has a ceiling. Hit subscribe if you want to see more ways math tries to trick us. And what should we solve next? Comment in this comment section down below.